Welcome to today's webinar, Tips for Building AI-Powered Apps Faster. We're going to be talking about some important principles in the development of AI-powered applications that are going to help you speed your time to value by at least 100 times, and perhaps more depending on your specific use case. Today's session is going to cover a few general principles that to keep in mind when designing AI-powered solutions, and we're going to recommend some approaches that you can take to get the most efficient use of your data and get yourself to a usable, deployable solution quickly. A little bit about Clarify before we get started. We were established in 2013, and we were launched into existence when our CEO won the top 5 places in the ImageNet competition in 2013. And so we've really been a leader in the space of computer vision, and more generally in terms of using artificial intelligence to understand unstructured data. And unstructured data can mean vision, it can mean images and video, but it could also mean audio and text classification as well. We are venture-backed with more than $40 million in funding from some great VC investors, Menlo Ventures, USB, Lux, Qualcomm, NVIDIA, Google Ventures, Osage, LDV Capital, and more. And we are also recognized as a leader in the space by Forrester, by Gartner. Recently, Forrester had us as a leader in the computer vision platform space, right alongside Google and Microsoft, and some of the largest companies in the world doing this kind of work. Now, to begin with, let's take a look at the typical steps a person would take towards building an AI-powered solution. You would begin by defining the problem at hand, and then you'd want to define meaningful metrics, so meaningful objectives. You know, what do you want this AI-powered solution to accomplish? And then you'd want to define sufficient accuracy for your models. And an important hint here is just that 100% is not the right answer for sufficient accuracy. But models are able to perform very well at very high levels of accuracy, but no model is perfect. And once you've clearly defined your goals, then the typical process would be to set about collecting data and collecting more data and even more data, and then labeling and cleaning and labeling and cleaning this data. And then after this laborious process of preparing your training data set with this collected and labeled data, you would then try various model architectures and training schedules and loss functions, measure your results, and hopefully things have gone well. And from there, you would deploy your models. And what we're going to suggest here is that instead of waiting all the way to the end of this very laborious and expensive process, to begin by deploying models, and then following a couple principles we're going to outline here in terms of either making the best use of existing resources and your initial deployment, or finding ways to build on your deployment over time to get the accuracy that you need and get the functionality that you need out of your models. So to visualize this in hopefully a helpful way, when it comes to creating artificial intelligence, there's typically, we see a curve that looks something like this. So we're going to be building a model that can understand the world in a certain way, and accuracy increases rapidly in the beginning as we add our initial examples, as we add our initial training data. And then as we increase computation, that is to say we train our model on this data over time, typically we're going to see a rapid increase early on, and then the accuracy is going to sort of taper off at a certain maximum level before we can hit 100% accuracy. And the question becomes, first of all, how quickly do you need to get to an acceptable level of accuracy? and what level of accuracy is in fact required, and is it even achievable? Again, 100% accuracy is simply not a possibility, either by humans or by machines. The first approach that we would recommend is what's called zero-shot learning in the academic literature, and that's kind of a jargon-laden way of describing pre-built models or pre-built subsets of models that are going to be useful to your particular application right out of the box. And Clarifai offers a variety of pre-built models, and if they are the best solution, if they are a match to the problem that you have, you definitely would want to start with one of these models and use them in production. And the vast majority of our customers are actually using our pre-built models just as is in their production application. Clarifai makes it easy to deploy these models, so you're going to be able to use our API. We have extensive examples on the website in various client languages. And we see here examples of a curl call where you can just make a call using the requestful library in whatever language that you like. But we do have additional clients in C#, PHP, Swift, Rust, Go, C++, in addition to Python, Java, and Node.js, which are documented extensively. Here's kind of a close-up look at one of our pre-built models. This one is the Apparel detection model. And this is used by many customers who are working in retail, specifically as relates to apparel, and recognizes over 200 fashion-related concepts. It works right out of the box. We have already trained this model, spent the time labeling the data, training the model, so that you don't have to, so that you can just use the API and plug the functionality of this model directly into your application, and it's ready to go right away. And that's exactly what many of our customers are already doing. The other model that I would want to draw attention to is Clarifai's general model, and it has over 10,000 classes, and this is truly the workhorse model here at Clarifai. It is used widely in many different use cases. It recognizes 10,000 classes, so it can offer you words, make predictions of certain concepts existing in your images. Like, for example, if we look here on the right-hand side, a train, a railway, a transportation system. This has been fed an image of a train, and it can the computer can automatically recognize the content of your images. And you can access all 10,000 of those classes, or just filter out a subset of labels that are useful to you, which is more likely to be the case for most customers. And then what if, to take this a step further, let's say we only have one example to feed our AI application. And can we do anything useful with that? Can we create a new model architecture that provides users with useful functionality? And the answer to that question is a great big yes. So what is called in the academic literature one-shot learning, more commonly known as visual search, is an extremely popular method for interacting with visual data. Visual search is used extensively internally within Clarifai as we prepare data sets and research data sets in various ways. And then visual search is also popular as an end product used by many customers. And so with just a single image for class, you're able to use the understanding of the world that, for example, you might have gotten from that general model, and use this to analyze your images, and then you're able to compare a new sample image to your database of images, and then you're able to rank order these images by visual similarity alone. And this takes no additional labeling or training or extra work, doesn't require any custom concepts. So let's take a look at what we mean by that. So Here we've got an example of what this might look like in the wild, where customers integrated this functionality into an app on their mobile phone. They're able to snap a picture, and they're able to search their database for similar images, and then they're able to offer other backpacks to the user for purchase within seconds. And then let's pop open the hood. So this is how visual search would be worked with and configured within Clarify's platform. And you can see we've got a database of various images. We're able to detect a backpack in an image and then use that backpack as a search query and search against a library, in this case, a catalog of images, as we might see on a retailer's e-commerce website. So we've identified the backpack that we're going to search with. We use this little search icon here, and we can now search the database for visually similar backpacks and use this to power product recommendations or research our data in other ways. The next step beyond this, so this visual search essentially is a case where we're taking one sample images and comparing it against many images in our database. Now, what if we have several sample images and several images in our database? What happens when we have a relationship like that? Well, in this case, we would use few-shot learning or custom training, or quick training as we call it here at Clarify, where we're able to, again, build on an existing model and add some new concepts, some new classes to create a new custom model that can recognize objects in the world in a way that we care about. And to just explain a little bit more about what we're talking about here. So if we have this input image here, we're going to, of the triangle at the top, there's various ways that that triangle might appear in real life, and it might vary in a number of ways. You know, we might see the triangle moving around the field of view, and there would be cases where that could matter a lot. Let's say we've got a security camera set up and we want to know when people are in a part of the factory floor that they're not supposed to be in. In that case, A and B would be very important factors to consider. It may be that when users are taking pictures of a given image, the orientation of the image may change, but it doesn't change the meaning of what we're looking at. It may just be user-generated content. Sometimes they don't orient the picture correctly, and so we might want to ignore seed. But at any rate, there's various ways that an image could present itself in real life and could vary, and we would want our models to be able to distinguish between what we care about and what we don't care about. So what changes should we ignore, and what changes are we trying to distinguish? And here we have just some more examples of how that might play out. So invariance and discrimination. What do we want to distinguish and what do we want to ignore? And this is where quick training becomes really convenient. So without rebuilding a model from the ground up, without having to decide on the model architecture, code it up, design the training schema, we are handling a lot of the basics for you behind the scenes so that you can just use a few examples, identify a concept that you want something to identify, you want your app to recognize, and then our quick training system is going to be able to automatically understand the differences that you care about and the ones that you don't care about. So we might, in the visual search example, take an image of this purse and then search for visually similar purses. But with quick training, we're able to give a few examples of what this purse might look like and then attach the look of this purse to a name so that we're able to say this is a Louis Vuitton bag and then just label it that way. And then we can search our database based on the concept of Louis Vuitton bag. And then it would bring up anything that looks similar to a Louis Vuitton bag. And we're able to add more distinctions. And again, here we're able to compare many items, many concepts, many sample images to the items in our database. And this becomes helpful in many different instances, but anytime you want to have these custom concepts recognized by name, or you want to have a system that can just basically tell which differences you care about and which ones you don't care about. With these solutions, you're able to deploy right away and start getting useful functionality right away out of your applications. And again, to think about that graph we looked at, you may be able to get a good way towards the level of accuracy you need right out of the box with these techniques. But if you're in a case where you have unique features, unique visual features in your data set that you need to identify that aren't really covered in a pre-built model, or you just need to bring that accuracy level up as high as it possibly can get, this is where you're going to want to use your deployed model to collect new example images to train future versions of your model on. So we had recently worked with a customer on a custom version of our not safe for work model. This customer had been this was an international customer, and just the nature of the content that they were working with and the way images looked were a little bit different than the initial training data set that we had used to train the not safe for work model. And the not safe for work model is used for moderating user-generated content generally. So we wanted to deploy right away, get some useful functionality by bringing the customer some way up that curve. And then we wanted to be able to collect data from real life examples and then use that collected data to train a new model that understands which labels they care about, which ones they don't, and also can identify the unique features of the data set, just these visual components that were present in their customers' user-generated photos that just weren't present in the initial training data set. And so what you see can happen is we've got them, their images going to the original non-safe for work model here in green. Predictions are made from that model. So it's the not safe for work model is able to call something, safe or potentially offensive and categorize things in different ways. And if it's able to make very confident predictions about images, those images then are auto-labeled and sent back to retrain the model. So we're able to take input images that their customers are generating. If the model's sure that it knows what it's looking at, we go ahead and label it and put it back towards retraining a new and more powerful model. In the cases where it's not sure about what it's looking at, then we can then route that data through to human beings to be hand labeled. And from there, we are able to enrich this data set and get us closer to the desired model outcomes. And you can see here how this work progressed. The initial training samples used to train the not safe for work model had been trained on almost 1 million images. And right out of the box, the accuracy score was at 92%. So really a high functioning model right out of the box, even given the differences in the data that they were looking at and the data that the model was trained on. The pseudo-labeled model, so this is the model that was trained on images that were auto-labeled through that first cycle, was able to also increase the accuracy, or was able to increase the accuracy of the model. Here we went to almost 93% at that point. And by adding the human in the loop in the active learning cycle, we were able to push the accuracy almost up to 95%. And this is a recent real-world example of this active learning at work. And you can see how deploying first was able to get them useful functionality right out of the box. And then using auto-labeling, we were able to add a significant number of additional training samples and push up accuracy with very little human labor required. And then the human workforce was able to label an additional 86,000 images by hand. And we really started to push that model to the maximum level of accuracy. In conclusion, I just want to point out that Clarify is really providing a whole ecosystem for this life cycle that is the development of AI-powered solutions. And give you a little bit of a sense of how that would work in terms of the data required to train these different models. And just looking at the platform here in the middle section, we can handle your input data, label your data either automatically through a process like we just described, or send it to a human workforce for hand labeling. Spacetime, our wonderful visual search tools, are very popular, and that's just that one-shot learning, which is incredibly easy to set up. There's no thinking of custom concepts. There's really very little work at all involved in getting a visual search solution set up. And then our Enlight training solution, Armada Predict, working together allows you to train new models and deploy them with literally just one click of the button. And our mesh workflows are this is the graph workflow builder that allows us to build this sophisticated business logic where you can send things to be auto-labeled, you can send things to your human workforce for labeling, and there's a lot of other options that you can build in using mesh workflows. And finally, just mentioning Flare, which is currently on limited invite, but is an exciting part of what we're working on, where we're pushing computation out to the edge to support live full motion video inferencing and other applications where you really want your computation at the edge for purposes of minimizing latency and addressing internet connectivity issues, etc. So we really provide the full life cycle, and we can get AI to your application no matter where it is. And finally, this is just kind of a review of what we talked about, where on the left-hand side, we have these different methods of model creation, where you're using a pre-built model or a subset of a pre-built model, visual search, quick training, deep training, active learning. You can see that as you go down this table, increasing amounts of data are required, and increasing amounts of engineering work may be required as well, but that you can get results, and you should get results right away by deploying your solution first and then learning from real-world data in production. Thank you for joining us. You can find out more at clarify.com.